Okay, so we're going to talk about the force of gravity versus mass lab that we just completed. And I'm going to go through kind of a walkthrough, a debrief of what we discussed in class. So in case you missed that day or you just want to revisit the topic, this will help you out. So what I did here is I pulled some sample data from a group. They had force of gravity, and I should put units on here, in newtons, and mass in kilograms. We always work in kilograms in physics because we work with very large objects. And then it was a straight line, and so they had the equation y equals mx plus b. On the y-axis was the force of gravity. The slope they came up with was 9.78 newtons per kilogram. Again, it's newtons per kilogram because newtons is on the y-axis, kilograms on the x-axis. And then the x value is mass, because that's the idea of living on the x-axis. And the y-intercept they came away with was 0.01 newtons. So the first thing we want to look at is this y-intercept. What does this y-intercept actually mean? Well, the y-intercept is telling us what the force of gravity is when the mass is 0. All right, so it's the force of gravity that acts on an object that has a mass of 0. Well, if you think about that, that's the force of gravity that acts on, if your mass is 0, you do not exist. So, force of gravity acting on a mass of 0 is force of gravity acting on an inanimate object. And so that means that we should get a value of 0. So this should equal 0. And if we look up here, we get 0.01 newtons. So that makes sense. Our data is confirmed by our logical analysis. So because it should always be 0, we're just going to drop this from our equation. So now we're down to force of gravity equals 9.78 newtons per kilogram times mass. And now we're going to look at what's the slope mean. So let's do a different color for slope. So then slope, well, that's something constant, as always. So we think back of the things that we decided we would not change or could not change, but we felt would affect the force of gravity. So it's something constant. And we came up with a list. And so the big things on the list was the distance from the Earth, the mass of the object, and the Earth itself. Now, if we look at these units here, we have newtons per kilogram. These are kind of weird units. They're something we've never seen before. So that's kind of interesting. What this is, it's related to the Earth itself. If you were to go to a different planet, you do the exact same experiment, you would end up with a different number here. So if you went to the moon's much smaller. It has a smaller mass. So therefore, you're going to have a smaller value right here. And we call this value something very special. All right, we call this the gravitational field strength. And because it's a special idea, we give it a symbol, and that symbol is a lowercase g. So this is the gravitational field strength for the planet Earth. All right, so let's be very clear about that. For Earth, it's equal to 9.8, so this group is very close, newtons per kilogram. Now this value does change a little bit based on where you are on the Earth, but not by much. And so kind of the agreed upon average is 9.8, maybe you've heard 9.81. That's the number that we're going to be using in class is 9.8 newtons per kilogram. So if you're ever on Earth, it has a gravitational field strength of 9.8 newtons per kilogram. And so what that means is we can replace this with this gravitational field strength, so we have the letter G. And so that leads us to our final thing. Well, what's the equation that we're going to walk away with? And so if we're looking at our final equation, we can now replace all this stuff with its ideas. So force of gravity is equal to, now we flip-flop the position of these, which mathematically does not matter. I think it's just aesthetics. So mg. So that's our new equation, Fg equals mg, where Fg is the force of gravity, m is the mass, And I should put units here. So force of gravity in newtons. The mass is in kilograms. And G is our new concept of gravitational field strength. And that has the symbol of lowercase g, and it is in units of newtons per kilogram. And so with this new equation, we can now calculate the actual force of gravity acting on an object if we simply know two elements. One, where is the object? Most likely they're going to be on Earth in most of our problems. And what's the mass of the object in kilograms? If we know those two pieces of information, we can do some simple math and we can determine what the force of gravity acting on the object is. So we're going to be using this equation in our upcoming net force equations, our upcoming physics problems, and we'll go more into that in some other videos, as well as classroom discussions. But this is our big takeaway from this experiment. The force of gravity is equal to the mass of an object times the gravitational field strength that it's thrusting in. So hope that helped, and I will see you guys next time.